by considering one dependent variable and one independent variable. Okay, so how I will find out this independent variable and dependent variable and how I'll do cross tabulation, I'll explain it to you. Okay, always your independent variable will be your demographic variable. Many times. Okay, sometimes you can use the factors, but many times your independent variable will be your demographic variable. That means the gender, age, education, qualification, experience in the investment stock market, what school type they have, material status, residential type, occupation, income levels. Okay, so all these things are demographic. Whether these factors will influence any other part, that I can do the comparison. Okay, so here what I'm going to do is I'm setting some hypothesis to test whether there is a relationship between these two variables. Okay, I'm going to test whether my income has any significant relationship with my level of risk taking. I'm going to compare these two. Okay, so for this, the first step, what I was supposed to do is I need to do the cross table for that. So what I'm going to do, I'm going to select these two data. I'm going to put it in a different Excel sheet. Okay, I'm going to copy it here. Okay, I'm done with this. Now I need to see how many of them have responded for 3 lakh 50 to 5 lakh. How many of them are responded for 1 lakh 50 to 3 lakh 50, like that. I need to define it. So for defining it, I'm going for doing the cross table. So how will I do the cross table is I'll go to insert. Okay. Next, I'll go to pivot table. Okay. Here they will ask you what are the tables you want to synchronize. Okay. Now I want to synchronize these two. So I'll click on these two. Okay. My next question is where the table has to be present. I want to present it in the same sheet only. So I'm giving existing sheet and I have to give location where the answer should come. Okay. I'm saying my answer should come here. Okay. Suppose if it is multiple, then select one location. Then give OK to it. So I'll have this. Things will be this way. Now I have to merge which has to be come in the row and which has to be come in the column. I have to map it up first. Okay. I keep my income in my row. I keep my level of taking risk in my column. My columns and rows are fixed. Next, I want to fix value for this. So what I'll do, you can click both the things. If you want level of income or level of risk taking or level of income, both the answers will replicate same only. So I'm now taking it level of income in the valuation. Whatever data I have created as jumbled was being segregated using my pivot table. Okay. Understood? Any doubts? Any doubts in doing this pivot table? Any doubts? Can I move further? Can I move further?
Yes, ma'am.
Okay. Once my data sets are ready, then copy it, paste it in separate sheet or something like that, or in the same sheet you can do it. Okay. Now I can do the analysis. Now I can do the analysis. Okay. So for analysis, if I'm going to test chi-square, okay, I have to set some hypothesis. Okay. My null hypothesis, there is no significant difference between my income versus my level of risk taking. My alternative hypothesis says that there is a significant difference between my income and the risk level of taking. Okay. So first I'll go to data analysis. So now I'm going to do chi-square. So for chi-square, this is my observed frequency. Okay, this is my observed frequency. For this, I have to calculate my expected frequency. Okay. So for calculating my expected frequency, my formula is row total, okay, into my column total divided by my grand total. I'll use this particular formula and find out my expected value for all these observations which I've taken. Okay, so the next column, I'll copy it once again. I will delete this observed values. I will delete this observed values because I'm going to fit in the expected frequency for all these values. Okay. So how will I do it? My row total is 21 into my column total is 14 divided by my grand. Then give enter. Okay. So for the rest of the things I want to do it right, what I will do is to drag the rest of the options, I want to freeze the cells. Okay. So for freezing the cells, I will add dollar symbol before the alphabets. If I do like that, that particular cell will be freezed. Okay. Same way, I have to freeze my this grand total also. For that, I will be putting dollar symbol and I'll enter. Now I'll run this. See, my grand total of the second row and my grand total of this, sorry, row total, column total, and the grand total. So like that, it will come for all. Same way, I'll do it this also. Okay, row total into column total divided by grand total. Then I will put the dollar symbol before the variables. And then I will try it. And the same way, the next one. Okay. So now I have found out my expected frequency. Okay. So I have my observed frequency. I have my expected frequency. Now I can test my chi-square test. Okay. So for testing the chi-square, I will start with equal to, because I'm using normal formulas to do it. So equal to chi-square test. Okay, I'll click on it. It will ask for actual values as well as expected values. Okay, my actual value is this. Okay, and my expected value is this. Give okay. I will get this 5. So this is my chi-square value. This value I'll compare with my p value. Okay, p value is 0.05. Okay. So this will help me to identify whether I want to reject my null hypothesis or alternative hypothesis will be identified using my p values. Okay, it's basically help you to identify the significance of that particular data sets. Okay, if my p value is 0.05, if it is less than that, I have to accept the alternative hypothesis. Okay, see the above, it is 0.0035. So it is less than. So in that case, I'll accept my alternative hypothesis. So what is alternative hypothesis? There is a difference between my level of income and the risk taking. Clear? Clear? Clear, everyone? How would I come to a conclusion, and how did I do the chi-square? Any doubts?
Chat box is empty, ma'am. I think
Sorry?
chat
Sorry?
box is empty.
Empty. So
So
everyone is clear.
everyone's
It's clear.
fine.
So can I go to the next test?
Yeah, clear, ma'am.
Okay.
Everyone is coming. Yes, it is clear.
Okay, fine. So we in inference statistics, we talked about chi-square, what it is, and we have also seen how we have tested also. Okay. So the next part is your correlation, right? And as I told you, correlation can be done only in the continuous series or continuous variable only we can. So continuous variable mean like this. Okay. So these are the data from Nifty. That is, what is the opening price or the closing price of Nifty, and the other side is the stock prices. Whether these both are related or not, I have to check it. And when you're taking like this data, okay, basically we will see the prices only. We will not see opening, high, low, volume. We will not see. We will see only the prices. Okay. Or if you're taking directly from NSE website, you will see only the closing price of that particular data sets. And here I have do the average for daily data, and I've compiled in the month-wise data. Okay. So I will take only my pricing. I'll keep it separate. Same way, here also I will take prices. And when I'm taking like this data, make sure that they both are even. One data should not stop with July, another should not stop with August. If it is like that, you need to either ignore the data set to have a proper result, or you put some values into it. Like put 99 in case of Excel. In case of SPSS, we can put 99. If there is a value could not be missing, you can put 99 in SPSS. Okay. Here, you can put some values into it, and you can continue with the data sets if you want the actual informations. Basically, we will reject it. If the data sets are uneven, we will reject it. We will not continue with it. We will stop with the values which is equal. Okay, so always make sure that when you're comparing like this, make sure that the data sets are equal in nature so that it gives you the proper result in it. Okay, so this is the Nifty value, and this is your SBI, that is State Bank of India's price value. Okay, now I'm going to compare with these two. Okay, so for this, I need to use correlation. I want to find whether they are related or not. So I'll go to correlation. CORREL, correlation. Okay, I will double click on this. Then it will ask for two values. Sorry. And I will close it. And correlation can be used only for two types of data. When you have only two values. Okay, for that only it is used. Some errors are coming. I'll just put it in a separate sheet. I think some error in my Excel, so it is not showing. Okay, so basically we will use this equal to symbol, correlation. Okay, you will write like this, open the bracket, you will select the data sets and you will put a column and you will select the other one. And if you close the bracket, you will get some values. Suppose if the value is greater than 0.75, okay, 0.75, it is greater than that, it means strongly they are related. If it is less than that, means it is not related to each other. That means it is less than 0.25 means it is not related to each other. Okay. And always your correlation value will lie between 1, +1 or -1. So we will say if it is a +1, positively related. If it is -1, it is negatively related, we will say. Okay. So that is the relationship between your correlation and regression. So correlation. Okay. Any doubts in correlation? How we will do correlation? Any doubts? Any doubts? Okay. So next we will move on towards your ANOVA. Okay. So for the same data sets, what I have it here, okay, I'll do ANOVA for this. Okay, I'll use my observed frequency. Okay, so this value I'll use it for ANOVA. Okay, so for doing ANOVA, I have to go to data, analysis. Okay, I'll go for ANOVA single factor. Okay on it, it will ask what are the data you will be inputting it. So I will input these values. Okay. And if you want to label anything, you can label. What is alpha means? A p-value. P-value is a alpha. So p-value can be 0.5 or 0.1. That means what is the level of significance which you want it, you can keep. Naturally, we will keep 0.05. So I'm keeping 0.05. And where the output data has to come, I just want it in the same sheet. So I will click it over here and I'll get it. So I'll get this ANOVA details. Okay, so I have a group of 4 because this is 3 columns and 4 rows. So that is 7 groups I have. Okay, and my average is 7. Average count is 4.5. Okay, and the sum is 9. Okay, and I have to see, to know my significant level, I have to compare this F and F, right? And I will also see my p-value. Okay, so my p-value is more than 0.5. That means in case of ANOVA, I'll be rejected. Okay, but we will not use it for the same questionnaire. We will use some other different variables. For your understanding purpose, I'm using this. Okay, so by seeing this p-value, I have to say whether we want to reject it or understand. But when in case of ANOVA, I have to see 2 things. One is my F value. Okay, F and F criteria value and P value. Both should coincide. Then only I can accept the hypothesis. Okay, here it's reject my alternative hypothesis. It says that there is no difference. Okay, and F value is also more than. See, it is not 1 comma, it is 1.93 and it is 199. Again, this also supports my null hypothesis only. Okay, so here for ANOVA, it says that there is no relationship between the income and the risk-taking limits. Clear? Any doubts? Any doubts? ANOVA?
There was Bhavna Sudhir who says she did not understand.
Oh, she could not able to understand ANOVA.
Yeah.
Okay. Calculation, she understood how to do it? Calculation part or interpretation part?
There is
Or I'll
a
start
note from the section where we started with ANOVA.
ANOVA, I guess. Okay, then I'll start. Okay. See, to make you understand only, I'm using the same variables. I don't want to use different variables. Same variables only, we'll do the testing. because we need to know final interpretation part only, right? So for that, I'm using the same variables. Okay. To use ANOVA, first I'll go to data. First step is go to data. Then go to data analysis. Okay. Today, I will teach you only ANOVA single factor. That means I will consider only one factor into it. I will not take multiple factors. Multiple factors means where I will use level of risk also, and I will also take their other investment options. Okay, I'm not taking like that. I'm taking only one factor. Either my income with my risk taking only I'm taking. That is single factor. Okay. I'll give OK to single factor ANOVA. Then it will ask for the input range. Input range means for which particular data I have to do the calculation.
Ma'am,
So
one
I
question
want to do the
is also
calculation.
coming. That is how to identify minimal data size for performing ANOVA.
Minimum data size for performing.
Yeah.
See, for doing ANOVA, your data set size, that is your options, you should have 3 variable options you should have, more than 3 variable options you should have. That means, say for example, income less than 1,50,000, 1,50,000 to 3 lakh, 3 lakh to 4 lakh, and 4 lakh to 5 lakh. If I have these kind of variables means I can go for ANOVA test. Okay, that means it should not be less than 2. If my variable options is less than 2, I cannot go for ANOVA. If it is more than that, I can go for it. I have answered your question.
Yeah.
So now can I continue with this?
Yeah.
Okay. Okay. So now I need to do the input of data. Okay. And then alpha value, it remains the same. That is nothing but your p value. And where I have to fix my output. Okay, whether I want to do it in the same sheet or I want to do it in the different sheet that I have to mention, I want it on the same sheet. Okay, I'm clicking on this. I'm getting OK to it. So once I give OK, I'll get like this ANOVA sheets. So this only I have to see. In this, what I will say is my difference of freedom is 2 between the groups. Between the groups means with my level of income and my level of risk taking, it is, and within the group it is 1 because it is 1. Okay. And here I need to compare my F value with my F grid value. Suppose my F value is more means I will accept my alternative values. Here my F grid value is more. That means I accept my alternative values. Okay, this is one thing. Second thing, I also have to see my P value. P value here is 0.45. So this is also more than 0.5. So in that case, I have to accept my null hypothesis. Clear? It's clear?
I guess yes is coming, no?
Okay, good. So hope you're all very clear with chi-square, ANOVA, and correlation. Am I guess right?
Yes, ma'am. There is no chat box, many queries yet.
Chat box. Now, let's do for a descriptive statistics. Let's test a descriptive statistics. Okay. Okay. I'll take this data. I'll take secondary data for doing the descriptives. Okay. For doing descriptive statistics, again, I'll go to data analysis. Here I have an option called description. I'll click on it. It will ask for input range. My input range is this. This is my input range. Okay. Column by or row by, it is not necessary yet. If you want any label, you can give it. Otherwise, if it is not required, that's okay. Where I want to keep my output is, I want to keep my output over this column. Okay. And it will ask whether you want summary statistics. Summary statistics means whether you want mean, median, mode. That is complete descriptive values you want. It is asking. Yes, it all. Okay. Means from my skewness, my curtices, everything will be given. Okay. All these things will be there. Whether you want to keep some level of mean, it's not necessary for descriptive statistics. Then K large. K large means what is the maximum number? That is K large. But we already, when we do descriptive statistics itself, we will get the maximum number. So in that case, I'm keeping my second largest number. Okay, I'm putting it as.
Madam, we cannot see the sheet where you're
You
performing.
cannot see the sheet.
Yeah, yeah.
Okay, then I'll do it early. One second. Now you can see the sheet.
Yeah, I can see, we can see the sheet.
Okay, fine. Now for doing descriptive analysis, I have to go to data analysis, descriptive statistics. I have to click OK to it. Now I need to put input of variance, so input range. I want to calculate for this. Okay. And then grouping and labeling of first column, it's all optional. Where I want the output over here. Okay. Okay, this means I want to go for the new sheets. I don't want to go for the new sheets. I'll do it in my existing matrix. Summary of statistics means it goes all the descriptive statistics. If you want mean, median, mode, okay, range, standard deviation, standard error, everything you will get it in it. Okay, so I want everything. So and crystal, everything I'll get. So I'll go for summary data. Confidence level of for mean, I don't want it for the descriptive data, so I'm not clicking on it. K largest is what is my highest number in this particular data set. We already know when we take the summary statistics and mean maximum itself. So what I'm doing is I'm taking second largest. So I'm numbering it as second. Same way, what is my minimum value is at K smallest. So minimum is also, I will get it in the summary statistics. So I'm going for the second smallest. Then I'm giving it. Sorry, there is some error in it.
Yeah, sure.
So there is some issue in the Excel, I guess. So that's the reason it is not accepting the numerical values. So I'll take a fresh Excel sheet.
All right.
Okay, so let me share the screen of the new data sets because there is some error over there. That's why it's not showing. Say for example, this is a value. Okay, so for that I'll do the descriptive statistics. I'll go to descriptive statistics, give OK to it. Input range, as I already discussed to you, I have to select the values which I want to see the mean and median. Okay, and we want to fix my data, so I have to click on it. Then the second level and largest level I go to, give OK to it. So I'll give this. Okay, so my average is 5 for this. Okay, for doing this average, I can see here also average at the end of your Excel sheet. Also, you can see standard error talks about what is the difference between your uh, uh, doing your calculation. See, it's a random number, so there will be some variations in it. So it is 0.81 as the variations you have. What is the mid value? It is 5. Mode in this particular data, we don't have any repeated information. So that's the reason the mode is not applicable. It's showing deviation from the mean. Your data sets were deviated by 2.6 percentage. Sample variations is a square root of the standard deviation. So it is 4.67. Percentile is negative here. That means we don't have any pattern over here because it's 2, 3, 4 like that only they have given. And skewness is also 0 because we don't have any linear over here. They have trend over here. So that's the reason your skewness is also 0. Okay. And it says that your mean median mode will also be same. Skewness is same because if you see the mean value and if you see the median value, they both are same. So that means it has a positive skewness. Okay, and there is no skewness in it. And what is the range between this? Range is nothing but your minimum value and maximum value. So minimum value is 2 and maximum value is 8. So that difference is your range. Okay, and my second largest is 7 and second smallest is 3. That means next to my 8, the next largest is, and next to my 2, the second smallest is 3. And total number of values are 35. Okay, and total number of count is 7. So these are the things you will get it in your descriptive statistics. Any doubts in it? Descriptive statistics? Any doubts in the descriptive statistics?
I think it's a no. Everyone is clear. There's no doubts.
Everyone. And where you will use it is this is basically used when you are doing analysis in finance field only. There we can go and do these kind of data analysis. Okay, fine. Any queries or questions till now? Can I go for the last statistical tools?
Yeah, I think there is no queries yet.
No queries. Okay. The last thing which I'm going to discuss with you is it's your regression. Okay. So actually the problem is the data which I'm having it here, I guess so. Okay. So I'll show correlation with this data. That means which I have entered. Okay. COREL. Very less functions I've given. to give two values correlation. Okay, so for this I'll do correlation COREL, my first range and my second range. Okay, 0.3. These two.
Madam,
This
the
is my X value.
shared, I guess.
Oh, sorry. See, actually, there is some error in the data what I have. So I thought that I'll create my own data and I'll show it to you. So for correlation, this is my X value that made my independent value, and Y value is my dependent value. For this, I'm doing my correlation. So what I'll do is COREL, one bracket. I'll click on this and I'll click on the next value also, close it. So it is 0.37. That means there is no relation between these two variables. Clear? So this is one way. Another way is I can also go to data analysis. Here I have an option of correlation. I can click on this. Okay, what are the input range? It will ask me. This is my input range. Output range, I can give it in the same column. So I want it here. Give OK. I will give it. Clear? Any doubts? So from the formulas also I can put correlation. From the data analysis also I can. Yeah. Okay. So now next comes the regression part. See, regression will also talks about your relationship only. Okay. For one or more independent or dependent variable, it will help you to find out what is the relationship. But the thing is, you can also see what is their prediction for it that can be identified in the regression. Okay, so the regression basically helps you to know what is the relationship between these two independent and dependent variable. When you have two or more variables, you can use this regression. Okay, how to do regression? Let's see. Same, I'll go to analysis. I have an option of regression. Give OK to it. This is my X value and which is my Y value. I have to give it. This is my X value. Sorry, Y value, and this is my X value. Okay. Here I have to fix my confidential interval, that is 95. Okay. And output, I want it in the same page. So I have to click the variables. In case of my regression, I have to use residual value. So I'll click on this. Okay. And then I'll give it. And it works. Okay. My R square is greater than 0.5. So in that case, for this data set, I will reject my alternative hypothesis. Clear? So I'll see only the R square value. Clear? Any doubts? So this the rest of the part I don't want it. Whether it is a predictive value I'm getting it here. The rest of the value I'll see only R square in my regression. And based on that, I'll accept or reject my hypothesis. Clear? Any doubts? Any doubts? You may ask why we need to separately prepare your ANOVA table.
No doubt, ma'am.
But here we have only F and F crit value is not there, P value is. So that's the reason we are preparing separate ANOVA. Okay. Yes. Any doubts? So what are the things we have seen? We have calculated how to calculate descriptive statistics. I've taught you chi-square, ANOVA, and then correlation and regression. Any doubts in this basic statistical tool? Because with this statistical tools, you can, whether if you're a HR or marketing specialization or finance specialization, you can do your research paper. And another more important, it is many what to say? We are getting many workshops related to ChatGPT with related to Excel also, right? So that is how to use ChatGPT with Excel is like if you don't remember these formulas, You can directly go to ChatGPT and you can get these formulas. So if you forget it, you can do it. But we discuss only less part in it, so you can easily understand. Because we used only two options, we go to that data, click on the data analysis. There you will get all the inputs. Okay. Any doubts in this? Any queries?
No, ma'am, no queries.
Okay. Okay. Thank you. And anything I want to discuss it here?
All the participants are requested if they have any queries, kindly.
Any any tools other than this if you want it?
Ma'am, hello.
Yes,
Yeah.
please.
Ma'am, can you please suggest some good books for the statistical analysis?
Statistical analysis.
I mean, the
books.
good books which have,
Using our SPSS.
I mean, whatever you have thought, can you please refer us some good books
See, as you see,
or
I don't-
website
no,
or
websites
website?
and all it is for websites and all not required. As you read more research paper itself, you can understand how these tools has been used.
Okay,
There's a way we can able to understand it. If you read the books and all now, it won't be that much. If you read a lot of research papers and other things, you can go for it. Okay.
okay. Thank you, ma'am.
Madam, there is a query by
Yeah.
Batavia. She is asking, can you explain how to add in megastat in Excel?
Megastatic for Excel. Okay, I'll show one. Actually, Megastatic will not be listed in add-on. Okay, you have to browse it and you have to open the Megastata in your Excel. Okay, see, for example, this is my Excel screen. I'll go to Office.
Ma'am, the screen is not shared. Huh?
Oh, sorry. Okay. See, in normal, you have to browse it and you have to add on your Megastata. Okay. So currently, it is not available here. Okay. Sorry. Anything else?
I think the chat box is empty. There's currently no other queries. Acha, she is asking how to download then. Megastat. How
What?
to download.
How to download it? Okay. Okay. I'll tell her. One second. See, install mega.excel. Okay, it will be supported by that, and you can use Mega's data. Okay. Okay. You can download the softwares. It will be available and it will support your Excel link, whatever the versions.
Yeah. Is there any particular site where they can access this particular software?
Access actually software part I was not aware of it. I'm really sorry.
Okay.
Yeah. Anything else? If you want to use SPS is also the same part in it. Okay. Can I give a short brief of SPSS also? You want it?
Yes, yeah, ma'am. I was not hearing what you said. Hello.
Okay. I'll give. Brief of SPSS.
Your voice is cracking. What you said, ma'am?
To use this on user just shoot small. Okay, they were asking whether I can download it with the organizing team. Ma'am, we don't have that support.
Yeah.
Okay.
Yeah. Yeah, I think no more queries are
Okay.
there. So.
Okay, no worries. I'll just give a short a brief about SPSS also that if the people have that, they can also use that. Okay.
Yeah.
So how to
Yeah.
input the data and how they can use it, I can show that. Actually, the SPSS is you can use any basic statistical tools book. Okay, you go with that. Okay, so that you will have some basic clear.
I think here will be data related on how to access the information that is a query, but otherwise all the concepts are pretty clear by you.
No.
Yeah. And
so it's taking some time for me to open the Excel SPSS. Yeah, it is opened. Okay. So when you open the SPSS, you will have a sheet like this. This is actual SPSS sheet. Okay. So whatever data you have it in the Excel. See, nowadays, as a researcher, we collect all the data through Google Forms. So we get Excel sheet, that spreadsheet we will get. So that spreadsheet itself, you can use this in SPSS. Okay. So by importing the data, okay, import data I have, whether you, how the data sets you have. So basically we will have it in the Excel. Click on Excel. Okay. So it will ask where I have to take the data. Now I'm going to take it from the desktop. Here I have the Excel file. You okay. It will take some few minutes to import the data. I'll give okay to it. Baby loaded. Okay. But if you are entering any data, then in that case, you have to start it from here. You have to do it in the variable view first. You have to name it whether it is a gender.
Screen sharing has stopped.
Hello.
Hello.
Yes.
The screen
Ma'am,
sharing.
I have a question.
Yeah, please.
Ma'am, the statistical methods we apply on a data which are variable. Suppose I am doing an experiment where data is not variable. For example, suppose I am using an organism which to test that that organism biodegrades a pollutant, and it is 100% doing that. Okay, so the data is not variable at all. And I have used 20 organisms of the same species, and they are doing it 100% degrading the pollutant. So which statistical tool should I use for that kind of experiment where the data is
Then
not
you can use
variable?
t-test. When the variable is not so, when the data is not like that, you can use t-test or f-test, sir.
And
So
what
that
about
I have
ANOVA?
discussed.
What
ANOVA
about
are in same phase, and when you have a dependent variable, you can use it.
okay? The
Okay, when the
ANOVA,
groups are same, yeah,
ah,
when the groups are same, then you can go for t-test.
when the groups are same. Okay, okay.
Same pattern, you can go for it. Okay.
I mean that they are the same organisms, but the
Yeah,
20,
same organisms, right? And when I want to find out whether they are a different one, I can go for it. And you will have only 2 or 3 variables, right? You can go for it.
okay.
Okay.
Thank you.
Yeah. Ma'am, so initially when you open any SPSS tool, the sheets will be blank. And if you have Excel sheet, you can import the data and the sheets will be like this. From this, I can do the analysis, whatever I taught you. So I have to start with analysis only. Okay. Suppose if I want to do chi-square, I can go to descriptor, have an option called cross table. I can click on it. And here I have to choose which is my row and which is my column. Okay. Say, for example, I've chosen income is my row and level of taking is this. Then click on statistics, chi-square I need it. Okay, click OK. Then you will get the data. Again, okay. Data will be run. Okay, so this how you can run the data sets in SPSS also. Clear, madam? Okay, in case of correlation also, I can go to analysis. Okay, I can use correlation, bivariate correlation. I can select the variables. I can do it. Okay, here I don't have correlation variables, so I'm not doing it. Yeah, so this how you will work both in Excel as well as in SPSS. Okay, any queries, ma'am? Or I'll stop here.
Chat box, there is
Thank
no
you.
more queries. I think
Okay.
everyone is satisfied.
Okay. Thank you. Thank you so much. Hope I've made it simple to understand.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Okay, ma'am, thank you very much for your input. And this was actually a very informative and very educative session, actually, which was much needed. And I hope all the participants had a lot of data and information understood from throughout this session. I actually heartfelt thank for your information. So the session is over for you, ma'am. Thank you very much. We will continue with the next
Thank
session.
you. Thank you.
Yeah. And the next session will start
Thank you.
within next 15. Thank you very much, ma'am. Rajesh, ma'am.
Thank you, Prem sir. Thank you, ma'am. Thank you. Bye bye. Yeah. Ma'am, can I leave the session?
Yes.
Hello.
Hello.
Hi.
Krishnan sir. Hello, sir.
Yeah. I had a comment to make if Anjashri madam has not left for a second.
Hello, Rajesh.
No, sir. No, sir. I'm here. Here, sir.
Yeah. Just in little input on the last question that was asked when the query was that in all cases my observations are the same. Then if that is not a variable, then you can kind of do what is called a rank test, where the end observation is either yes or no.
Rank, actually, in that case, they have to put ranks for each and every variable and then they can do it, sir.
Because
They
sometimes,
mentioned us they didn't do any ranking.
yeah. So if the end observation is in all cases the organism is metabolizing, then there is no reason for applying any statistical test because there is actually no variable.
Yes.
The only time he can do that is if he talks about the time required to use up all the pollutant. In one case it is
Pollutants, yes.
in one case it is 4 hours.
Yes.
In that case you can
Correct,
apply
sir.
statistics not on the final observation because that observation simply means it is metabolizing. So there is no statistical involvement in that type of observation. So thank you. Thank you.
So that means, hello, ma'am. Hello.
Yeah.
So that means there is no need to apply student T-square test or any test. If the
See, if you are doing an experiment where you are looking at 20 microbes and you're
Yes.
finding that all of them are able to metabolize it and no starting material is left, then your
Yes, yes.
observation is complete degradation. So there is no statistics, because statistics is only applied when you want to look at differences between microorganisms. And in this
Yes.
case, because your end observation is the same, there is no need to actually apply any statistics. The
Sir, but
statistics will come is
yes.
if you are talking about time required. For example, in one case it takes 1 day, in other case it takes 2 days, and then you want to say whether one is significantly different from the other or not, then you can apply statistics. But if your end observation you have kept as
Yes.
all used up, then there is no question of statistics. You just simply say out of 20, 18 are doing it, 2 are not doing it. That's all.
Sir, what if we change whenever we feed the organism with the pollutant, if I change the concentration, from increase the concentration of the pollutant gradually and observe that the efficiency of the biodegradation has been increasing or decreasing accordingly. So in that case, I am getting the different result. So in that case, should I apply a statistical test?
See,
And if yes, then what kind of statistical?
so now you have a variable, right? Now you have a
Yes.
variable where you're
Yes, yes,
seeing the concentration and you're seeing a difference in the time required or
yes.
the
Or
speed.
the rate of the biodegradation has
Exactly.
changed.
Now you'll have values for the rate. Now
Yes, yes,
observation will not be completely metabolized or not metabolized. It will be completely metabolized after 2 hours, completely
yes, yes.
metabolized after 4 hours. When
Or like if I keep the time period same and if I get the 50% is metabolized or 75, yes. So in that case, should I apply a student T-square test?
then you can apply, as madam says, the statistical test where you say when at two different concentrations, when you see 50 and 55%, is that
Yes.
significantly different or not?
Yes.
Or it's just same.
Okay.
It's observation.
So student T-square test will be applicable in that case.
I think that's when madam will tell you which steps to apply.
Okay.
Okay.
Okay. Thank you, sir. Thank you so much.
Thank you very much. Thank you, madam. And
Thank you, Rajeshwari madam, for allowing me to share this.
Yes.
Thank you, ma'am. Thank you, ma'am.
Thank you, sir. Can I? Yes, ma'am.
yeah. Krishna sir, actually, we will be continuing with the next session after 10 minutes.
Sure.
There will be a small 10 minutes break.
Yeah. I'll join in maybe about 5 minutes.
These sessions?
Yeah, sure. I'll share the screenshot. Yeah.
Yes, ma'am. Thank you so much, ma'am. Bye.
Yeah, bye. So we will meet after 10 minutes. That is by 12:45 we will meet.
Sure.
Yeah.
Okay, ma'am.
Thank you, sir. Stay tuned. After 10 minutes, we will continue.
Good afternoon, Nisha madam.
Good afternoon, sir.
The surname is not a common surname. I actually had a pharmacy student with that surname. Maybe she's related to you. I don't know. Deepa. Somewhere in your relation. Vela Yudhan.
Sir, actually, myself Sneha Pandey and
So
joined from Nisha Madam.
So ask Nisha ma'am whether she knows
Yes, yes.
anybody named Deepa. Student.
Same surname. Sir is saying we have a unique surname, and one of our students.
That's not my surname.
Okay.
That's my father's name.
Yeah. Okay. So I had a Deepa Vela Yudhan as a student. So I thought maybe you know her. Pharmacy student.
नहीं, pharmacy में
कोई भी नहीं. Okay.
नहीं.
Okay, so to all the participants, let us start our last session of the day. Good afternoon, one and all. Myself, Sneha Pandey. I welcome you in another motivational session, and I am really feeling very privileged to introduce our anchor and speaker of the afternoon session, Professor Dr. Krishna Iyer, sir. So let me introduce about, give a brief information about him. Sir is a professor of pharmaceutical chemistry and currently heading the position of IC principal at Bombay College of Pharmacy. After his MPharm degree from the University of Mumbai, Dr. Iyer has completed PhD from University of Minnesota, USA. Sir also completed 2 postdoctoral fellowships at University of Washington and at Warner Lambert Farm Research. He is very passionate about research, and some of the keys and interesting areas are mechanistic drug metabolism, evaluation and development of in vitro drug metabolism and their assays, population phenotyping and genotyping, and drug-to-drug interaction predictions. Sir has also graced the editorial boards of national and international journals of some of the repute letters like Indian Journal of Pharmaceutical Sciences and Asian Chemistry Letters. He is also credited with several research publications in national and international journals, recipient of many awards, accolades. Few are like James R. Gillette Award for the best paper in drug metabolism and best paper award in pharmacology and clinical pharmacology. He has guided more than 50 MPharm students and 70 PhDs, more than 50 publication grants, and grants more than 202 crores. So, sir, I welcome you on the behalf of management of KV Pendharkar College and IQAC. I welcome you, sir, to enlighten our students on the topic of crafting research publication. So I declare the session is open to all. And sir, now you can share the screen.
Yeah, before I share the screen,
Yes, sir.
thank you very much to madam and I think Suman madam and Sandipta madam, if I
Yes,
remember right,
Yes, Sandipta. Yeah.
for inviting me to give a talk at this very esteemed online workshop. Uh, I hope I am audible at the moment, that there is no issue with the audio. Uh, just one quick correction, what madam said. I have not guided 70 PhDs, it's only 7. Okay, it's usually more difficult to guide PhDs than masters. So it's only 7, so not 70. Okay, so I'll just share my screen and this will stop other screen sharing. I'll say yes.
Yes, sir.
Okay, so
Sorry, sir.
no problem. I feel good, but it's not. I shouldn't be taking credit where it's not due. Okay. Uh,
Okay.
so here I'm going to go in the full screen mode. Uh, hope you can see the full screen mode. And
Yes, sir.
let me pick out my
Visible and you are audible also.
and here is my pointer. Hopefully you can see my pointer here.
Yes, yes.
It's okay. It's a bullet. Okay. So as we close the 2-day online workshop, the topic which has been kind of allocated to me.
आय तरी नाही भेटली ना भेटल आहे ते जर नाही भेटले ना म्हणजे आयर तरी झालं ना भेंडी डिपार्टमेंट मध्ये पप्पा
Somebody is
म्हणजे मैं फिर छाती टोकी बोला मेरा साला आईएएस में आया है सॉरी आईआरएस है
Shivam,
हाँ?
Shivam mute.
Oh, okay. Thank you. Thank you, Shivam.
Sorry, sir, for the
So,
interruption.
so the allocation is crafting research publications, which is another way of maybe saying how should we do technical report writing. And I'm presuming all of you are in one way or another engaged in doing some sort of research, and usually the culmination of whatever research efforts that you have is sometimes a very simple lab report in many cases to the other end of the spectrum, which is getting a research publication or actually even filing a patent if you have generated adequate intellectual property. So in this afternoon, I may not be able to cover all aspects of technical writing, but I will kind of refrain myself to maybe how to write a typical research publication so that you can get it peer reviewed and have it published in your name. Okay, so and here we go. And again, this session is open to discussion. So if anybody wants to ask a question at any time, I would be okay with you simply unmuting and asking a question, and I will pause at that time and maybe clarify and go forward. Okay. So, in terms of what I'm going to talk about this afternoon, I'm going to talk about 4 aspects of what we call as scientific writing or technical writing or publication, whichever name you want to call it, which is what exactly is technical writing or scientific writing? Why do we need to do technical writing, or why do we need to publish? Then why do we need to learn how to write a technical report? And if you are really interested, then how do we exactly do it? Okay, so I'll kind of go in these 4 steps. Okay, so to begin with, what is technical writing? Technical writing can involve one of many things. It could be your simple master's thesis or your PhD thesis, or even at an undergraduate level, what we call as a project report. At a slightly higher level is where you actually write a manuscript with the intention of getting it reviewed and published. And this could be what is called as a short communication or a full research article. Or if you have adequate expertise in a given area, you might actually write a review article based on whatever has been accomplished in your area of expertise. And many a times, you might also write to an editor when you have a comment or a clarification regarding a already published paper. Another type of technical writing is where you actually write a book chapter. In this case, maybe even edit a full book or write a given chapter related to your domain of expertise. Then you also have other types of scientific writing where maybe you could write an editorial or article in a newspaper or in a college magazine, or you might actually give your perspectives when you're invited to talk about a certain topic as kind of like many times a short note in a journal or something like that. And of course, you always all need to write a lot of grants in order to generate finance for your research, and that also involves in a sense writing things in a more technical fashion. Okay, so there is a whole gamut of what you can do in terms of technical writing. And this afternoon, we are going to concentrate on how to write maybe a research article, and maybe I'll spend a minute or two in terms of what is a review and how theses differ from all of these types of articles. Okay. The second question is why do we need to do all of this? Why do we need to publish at all? Okay, and to answer that question, the main purpose of scientific writing or technical writing is to kind of communicate whatever new findings that you or your group have come across. Okay, in addition to this, if you are able to publish it and establish it, then it actually determines the ownership for that specific body of work or that facet of science that you have done or the viewpoint that you have kind of put forth in the publication. Okay, so there's mainly two aspects to it. One is to communicate what you have done, and also to kind of take ownership of the work that you have finished or generated. And the reason we need to do this is because if you look at science as in a more philosophical sense, it is a collective enterprise. Rarely can one do science and generate knowledge entirely on our own. And there are only maybe a few people who are what are called as these novel thinkers who don't rely on anything that is already there and actually generate something very, very new, most of us fall under the category where we actually look at things which have been done by others as a starting point and maybe add to it, and therefore we become part of this collective which is kind of working towards increasing the knowledge that is present on the earth or in the universe. Okay, and the overall growth of science depends on the work and exchange of data and ideas, and that's the reason why we kind of publish and share our findings with the others. And of course, from a financial perspective, when you write grants and when you write solicitations of your research ideas, the intention might be to get some financial assistance uh, from what are called as venture capitalists, so that you can continue to do your research. Okay, so that's the reason why we kind of do technical writing. Okay, the thing is, why do we learn to do it? Don't we know how to do it? Sometimes you may not. So we need to learn how to do this writing, because in many cases you may have never been formally trained to write a research paper or a publication, and invariably in your life you come to a point that you have done some work and you want to get it published and you have no idea how to do it. Okay, but the other reason is many times we are good at writing, but we may not be good at writing things in a very logical, clear, and concise manner. And given the constraints of how many pages we are allowed to use as part of a research publication, or even considering the fact that many times publications require cost per page, you have to learn how to write logically, clearly, and very concisely, so that you don't waste okay. And of course, in the end, you might do great research, but if you're unable to present it correctly, a poor presentation or reporting of information can actually negate all the merits of all the good science that you have done or the discovery of invention you have made. Okay, so even from a in a selfish perspective, if you have done good work, you better learn how to write it in a nice fashion so that others can appreciate what you have done. Okay, and that's a need for the hour. And if you look at reality, you will find that if you I've never written a research paper, the initial phase of writing a research paper will improve very, very quickly. And that is typically in most cases. It's only a little later when you want to kind of really become a good research paper writer that it actually will start becoming more and more difficult. And after that initial jump, you might find that you reach kind of like a roadblock and you are unable to find your own style and own flair in terms of how to write nicely. And that requires a fair number of experience as you start getting good at kind of collating the information that you have generated and presenting it in a way that can be published very, very quickly without too many back and forth corrections occurring. Okay, so that's why we need to learn how to write scientifically. Okay, so given the fact in terms of what is writing, why we need to do a publication, and why we need to actually learn how to do a publication, I'm going to give you a kind of like a bird's eye view of how to actually approach this process of crafting, as you would say, or generating the manuscript so that you can send it for publication. Okay, so how do we get started? And what are the things that are needed as we get ready to, take the information that we have and put it in a more organized fashion for publication? Okay, a scientific publication, as you have realized, is a written or a published report, kind of describing your many times original research. But the more important thing is, whatever you do, it has to be in a form where other people who are experts in your area or in your domain are able to repeat whatever experiments that you have done and also test the conclusions so that there is some validation of what you have actually done. Okay, if you are doing research which nobody can repeat based on how you are presenting your work, then that work actually has no value at all. Okay, so it is very, very important that when you write a research publication, you do it in a way where somebody else who's an expert in the same area is able to actually repeat what you have done. Okay. The other aspect is that when you do send your work for publication, make sure you send it in a journal which is ready available to the scientific community. Don't look for a journal which nobody reads, and therefore your science might get lost, or don't make the mistake of trying to get it published in what is called as fly-by-night journals. Okay, nowadays you'll find a lot of predatory journals which will send you a lot of mails saying that you send your stuff to us, we'll get it published in 2 or 3 days for a nominal charge. And these type of publications have actually no value at all, because that same journal will disappear after 6 months. So if you get a publication in that journal, for a few days, you might write it on your CV, but after a while you can't even write it on your CV because the journal doesn't exist at all. Okay, it never really existed for a long enough time to be an established journal. Okay, so that's very, very important. Sometimes in order to kind of do the numbers game, we send it for publication to a place which has no what you call standing in the overall scientific world. Okay, so make sure you don't do that. Okay, so if you look typically at a research paper or a scientific paper, you will find one of these two ways where your findings are organized. Okay, one and the most common way is where you have an abstract of the work you have done, followed by the introduction to the research that you are talking about, then a section which is referred to as the method section or experimental section, where you actually outline how you have done the experimentation and how you have generated the data and actually analyze the data. Then you actually present the results of your finding, and finally you discuss the value of the results that you have generated in the broader context of your scientific area of expertise. Okay, of course, at the end of this will be a section which is referred to as the references, which kind of validate many of the things you are writing. Another way of writing a research article, and this is seen in many chemistry journals, is that you start with an abstract, go to the introduction, go directly to the results and do the discussion, and then the experimental section is at the end for all the people who are really interested in actually following that experimental protocol. Okay, but by and large, you will find most of the journals you will encounter, at least in life sciences, follow the format or the sequence which is written here on the left. Okay, which is abstract, introduction, methods, results, discussion, and references. Okay, so what I'm going to do is kind of talk about all of these subparts of a research paper one by one. Okay, but what I've not mentioned in both of these diagrams or a cartoon is the first part of a research paper, which is the title. Okay, so everything starts with a title. Now, as you prepare to write a research paper, it is very imperative that you keep in mind two things about your research paper. One is who is the audience or who is the reader? Okay, who are you writing the paper for? What is it that they know about what you are going to talk about? Why do you think they will read your paper? And how they will approach the science you have presented or the material you have presented? And the second and even interesting aspect of writing technical report is whether your intention is to inform the people about the science you have done, and in some cases it might actually be to persuade. And when you talk about persuasion, it is when you actually want to get finance for your project, or you have generated a hypothesis or an idea which is very, very new, and you're trying to persuade people to accept your thought process. Okay, so these two things actually form the backbone of how you kind of write the paper. Always remember who it is for, and always remember why you are writing the paper. Okay, so if you then look at the way somebody is going to look at what you have kind of published or presented, they are going to look at one, the way you have presented your research work, which is your style, which includes, how you have structured everything, the overall language that you have used, and how you have illustrated your findings. Many a times you will find a lot of visual aids, which is part of a paper like a graph or a chart or something like that, and that helps somebody to understand the information that you have generated. And the second thing is, how does it overall appear in terms of how your grammar is, your punctuation is, your spelling, how you have formatted the overall paper. Okay, all these are very essential towards somebody kind of looking at your paper and saying, oh, that's a very well written paper, it's good, or saying otherwise. Okay. So, so if you kind of look at the lifetime of a scientific paper, you'll find that we can broadly kind of divide it into three stages. One is kind of what you call as generating the first draft of the research paper. And usually speaking, this is the slowest step. Okay. And for two reasons. One, many a times we are inherently lazy in documenting the work we have done. We don't have a drive many times to write up what we have done, and whenever you start writing, the amount of background information that you have to collect in order to generate that first draft many times acts as a kind of a barrier to even start writing a research paper. However, in case you are done with that, then the next stage, which depending on how you have written the first draft, could be very short or very, very long, is the revision part. Okay, and I've written here as revising, 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 and that depends entirely upon how you have written it and how your guide or supervisor is going to look at what you have written. And many a times it is not uncommon for a research paper to go back and forth up to maybe 10 to 15 times before both you and your research advisor or supervisor agree that now we are ready to send it to the publication house for evaluation. And then after you send it, you might actually go through a few more rounds of revision, depending on who your referee is, who's looking at your work and what the queries are in terms of what you have done. And then finally, if your paper gets accepted, then you reach a point where you call the finishing line, where you get the galley proofs, you do the final correction, and it actually appears in print or it appears online, whichever the case may be. Okay. So usually these two phases, which is writing the first draft and revising, take the longest time. In my case, over the many years that I've written papers, there was one paper which actually me and my boss revised close to 40 to 50 times before we actually decided to send it. Okay, so it can be very nerve-wracking, and you need to be a very, very patient person as you go through this process of revising what you have written, so that it just sounds or it just is correct, so that there is a less trouble later on when you send it for actual publication, and the reviewers don't need to do anything at all except look at the science. Okay. So now every paper or every publication has a few things that you have to remember. One is every paper will have either an author or two authors or a whole list of authors who have contributed to the science that is being published. Okay. In this case, it is very, very important that you or your group do not do what is called as either gift authorship, that is kind of put people's name who have not contributed at all to the research work, just so that you can get more publications per individual, or do the other error where you forget to actually include the name of somebody who had contributed to the work you have done. Okay, in a joking way, I've written it here where it says, okay, no, it's my wife's turn to be first author on your paper. Okay, this is called as gift authorship, where just to kind of pat each other's back, you start putting everybody's name on the paper. That is a no-no. Okay, and the other thing is, you have to also remember that in nowadays, most of the research houses or publication houses ask you to state your conflict of interest. In other words, uh, if you have any personal interest in the findings of your research, either financially or in terms of intellectual property, you have to actually state that so that people can then read what you have presented in the context of the fact that you have a personal interest in that research. Okay, a simple example would be, let us say you are the owner of a company which is selling a product, and the research paper you are writing is all the good or the merits of that product. You have to actually tell the audience that you are the owner of the company whose products research is being presented, because then they will read that in the proper context. Okay, and nowadays another issue which we have to always worry about is what is referred to as plagiarism when you write research papers. Plagiarism per se means presenting work or ideas from another source as your own, sometimes with or without the consent of the original author. Okay, and here what happens is you start putting things which are actually not yours in your work without fully acknowledging the fact that they have come from another source. Okay, and if you get caught for doing plagiarism, you might actually have a legal proceeding occurring against you, and many times it might end up to the extent that you might actually be jailed in some cases, or your research paper might simply be removed from the journal, or what you call as retracted in case they find that you have plagiarized. Now, in this regard, you can have plagiarism of different types. Okay, one is called as complete plagiarism, where what you have done is just taken somebody else's work, put it in your paper, and never ever mention that you have done that. Okay, a typical example of this, which we see in everyday life, is many of the old songs are again presented with a few instrumental additions as remixes. Okay, this is a typical example of complete plagiarism. Just take it and never quite tell people who was the original songwriter or a music director, and just use it as your own. The second thing is sometimes what is called as verbatim plagiarism, where what you do is take very, very specific sentences from another paper, put it in your paper exactly in the same way, and never actually state in your paper that this is taken verbatim from another paper. Okay. An example of this, again, if you look at the world of music, is if you remember an old movie, Jis Desh Mein Ganga Bahti Hai, and a newer song, which is Ram Teri Ganga Maili, both have this one sentence, Hum Us Desh Ke Vasi Hai. Okay, so the Ram Teri Ganga Maili, which came almost about 30 years after that old one, has actually used this sentence. But I don't know whether they actually acknowledge the fact they took it from this other song. Sometimes you can also do what is called a self-plagiarism. Self-plagiarism is where you take material from your own publication and reuse it in a new publication. Now, you might think that because it is your work, you have the freedom to do it. But you have to realize that many times when you get something published, that publication involves transfer of copyright to the publication house. And at that point, the ownership is with the copyright house. And therefore, even you as yourself don't have the right to take stuff from your own paper and put it in another paper. Okay, an example of this type would be like if you listen to the two songs, Aaja Re Pardesi and Ghadi Ghadi Mera Dil Dhadke in Madhumati. In the second song, Ghadi Ghadi, there is a small part where the tune of Aaja Re Pardesi is part of the Antara. Okay, so here the same musician has used his own piece of music in another song. This type of occurrence in science is called as self-plagiarism, and that is actually not allowed. Okay, so you have to even cite yourself and make sure that you say that this was taken from another paper, and that too it has to be in a limited fashion. Another type of plagiarism is incorrect reference citing. Okay, here what you do is even though you have taken something from somewhere, you don't correctly attribute it. It's almost like a little bit of a fraud that you say that you got it from somewhere, but it never came from that place. And of course, last and not the least is what is called as accidental plagiarism, where you don't even know that you are plagiarizing. And the reason is because you have read that somewhere and it is just there in your mind. And when you're writing your own paper, those same sentences have come through, and you don't realize that you actually remembered it from a paper or some presentation which you have heard. Okay. An example of this is our Anu Malik ji, who says that all the good music is taken up. So if I write a song which resembles an old song, what can I do? Okay. So if you look at the song Rahe Na Rahe Hum versus Sagar Kinare, they are the same meter. Yeah. So I don't know whether it was accidental plagiarism or intentional, but this type of plagiarism also occurs in science. Okay. So make sure when you write a research paper, that whatever you are writing to a great extent is generated by you, and in case you have taken information from elsewhere, make sure you actually cite that. And this is also very true when you are writing reviews, where you take figures and graphs from another paper as part of a review. At that time, you actually need to write to the publishing house and get copyright permission to put it in your review article. Okay, so all these things have to be done in preparation for writing a paper. Okay, so that taken care. Again, we come back to the sequence here. Your title, your authors, your abstract, and introduction, and we'll kind of go through that one by one. Okay, so the first thing is the title. Okay, the title is very, very necessary because this is the one which everybody is going to look at before they even start reading the paper. So your title should provide adequate information describing the contents of the paper. Okay, and the reason this is important is because nowadays many times when people are looking for information, they're going to do what is called an electronic searches or what they call a digital searches. So if you don't title your paper appropriately, they might simply miss your paper and never find it. Okay, and the other reason is if you correctly title the paper, you can actually attract other researchers to try and read your paper to give you more what you call as visibility as a scientist. What your title should not be is uninformative, unattractive, uncomplimentary to the content, or too long or wordy, so that people get disheartened just looking at the title. Okay, so make sure you do things correctly. But how do you generate a title? Okay, to generate a title, what you have to do is, since you have kind of written the draft of the paper, you look at the key words of what you have written and rank these words according to what you feel is the order of importance. And then the idea is to kind of put together these keywords correctly to construct kind of like a title. Okay, and when you do that, if you find the title is too long, then very systematically you remove the least important keywords, and then in the end, kind of what you call as converge toward a title, which is kind of talking about exactly what you have done in the best possible manner, so that your article can be attractive to somebody to try and start reading it, and also it is digitally easy to access what you have done. Okay. However, easier said than done. Many times this does take time in write-up, getting the correct title. Okay. The second thing is authors. As I kind of indicated to you, you should not be doing gift authorship or forgetting to include somebody as an author. Then other than that, in terms of the order in which the name of the authors appear, there are actually no specific rules. And you'll find that in general, there are two approaches to how author names are listed in sequence. Some groups, what they do is they write the name of the student who has done the bulk of the research as the first author, while the group leader or the what you call as the mind behind the research is usually the last author. However, I've also found that in many cases, the guide or the supervisor wishes to put their name first in a research paper and then put the others in terms of decreasing contribution. Now, this is a very sensitive issue many times, especially when you have situation where more than one person has worked on the research work and all have contributed kind of almost in a similar fashion. And therefore, it's very difficult to figure out who to put first and who to put second. In that case, many a times you can actually put a footnote in the paper saying that the following authors contributed equally to the research work and that the names are simply appearing in alphabetical order, so that everybody gets due credit. The reason for this, fight to be the first author is because when you look at how research papers are written, many times when you cite references to the work which has been done previously, you generally tend to write it as the name of the first author and et al. And others. And therefore, when these research papers get cited, only one of the names among the many who are part of the research work actually ends up being cited. And therefore, a lot of people like for their name to appear in print more times. And therefore, that ambition, jealousy, and egotism start getting involved in terms of who wants to be the first author, while who doesn't want to be in the middle, and so on and so forth. Okay. And sometimes this can get very, very tricky. So the solution to this is you decide on the authorship before many times you even start the research, or at least before you start writing the paper. Okay. The general rule is that people who make a substantial intellectual input to the whole process should have a priori right to authorship. And many a times, depending on the group's philosophy, the one who has actually done the lab work gets first authorship, and the person who has got the most intellectual contribution ends up being the last author. And many times when we as scientists read a paper, we also know that the last name is actually the group leader, and that is now kind of almost accepted in the world of science. Okay, but again, in case there are conflicts, the best solution for deciding authorship is actually goodwill among the researchers. If you don't have goodwill, this can become very, very tricky, and as in many cases resulted in fights and what is called even legal implications. Okay, so be very careful as we do this part. Okay. Now, what we meant by intellectual components that I just talked about, which kind of gives you a right to be an author. One is that are you the person who generated the idea that resulted in the research being carried out in the first place? Okay. Or have you contributed to the reasoning that converted these ideas into a testable hypothesis? Then did you actually do the testing of the hypothesis in the correct experimental fashion? And after you generated some numbers, were you the one who did the interpretation of the results in relation to what you have done, and also in relation to what is already known? And then who is the one who actually drafted the paper? Many times what happens is you generate information and it sits there, and somebody else starts looking at it and says, okay, let me put it all together. And they actually have not done the science, but they're very good at collating this information. Even they have a place in the authorship. Okay, and also remember, after doing that, you do need a lot of editing, and that also requires a sort of intellectual input. And finally, when you send the paper to the publication house and somebody reviews and asks questions about the research work, who is the one who is answering the queries of the reviewers? Okay, so all of these actually, if you are doing, then you actually qualify to be a part of the authorship of the paper. Okay, so make sure that if your name appears on a paper, you have done at least one of these things. If not, then try and get the name removed because you're not supposed to be there. Okay. Now, once you have done the title and the abstract, here comes the first part of the research paper, which is the abstract. Okay, your abstract is kind of like a mini paper that actually puts together everything that is going to appear later on in the paper, but in maybe even 1/15th or 1/20th of the original space, which is being occupied by the rest of the thing. Okay, so this is a exercise or what you call as effort in what is called as précis or ultra précis writing in many cases. Okay, because many journals will tell you that abstract should not be more than 300 words or more than 500 words or so on and so forth. So that puts a lot of pressure on you to kind of put things in perspective about the entire paper that is being written in such a short space. Okay. However, you need to do this correctly because this is the driver that will, tempt the reader to read the full paper. Okay. Everybody likes to quickly look at the abstract and see whether it's worth their time to actually go through that entire paper. So if at that point itself, somebody gets disheartened or kind of what you call discouraged from reading the whole paper, then you have lost that person, and that paper will never be read by that person. So you need to put a lot of effort in writing this abstract. Okay, and overall, the abstract should have why you did the work, how you did the work, what were the major findings, and the major conclusions. All of this have to come as part of the paper. Okay, one thing you should never do in an abstract is talk about a few things and later make a statement that all of this will be discussed or stated in the paper. Okay, an abstract is not a little paragraph which tells the paper, oh, all the things I'm going to talk about is somewhere else, and so just start reading the paper. No, it has to be part of the abstract. So your final result has to be part of the abstract. The only time you can maybe talk about will be discussed or stated in the paper is when you're writing a review article, where you might actually write this, because when you write a review article, it's very hard to distill everything into an abstract. So at that point, the abstract will only tell somebody what the review overall is talking about, and that the nuts and bolts of what is being said is actually going to be in the paper. But a typical research paper should never write the other things will be discussed in the paper. Okay, that is not the place for the abstract. Okay, so title, author, abstract, and now the main paper starts. And the first section of the main paper is the introduction. And this is what will orient whoever is reading your article and their thought processes towards what is going to come later. Okay, and at this part, you are also going to, in a sense, talk about all the logical steps that you have taken towards kind of building your hypothesis and kind of the need for doing this study that you are writing up about. Okay, so but if you go deeper into the introduction section, you will find that it will have a little bit of a summary of the background to the research that you are going to talk about, just enough, but not so that it takes up all the space of the paper. While writing this introduction, you have to make sure that you tell the reader where there are gaps in the knowledge about the subject, and that the fact that your work maybe is related to kind of filling this gap, and so that there is a context to the investigation that you are talking about. Now that you have set this up, you actually define that gap or the problem and state the question which will answer or fill the gap, and then present an idea or a hypothesis to try and fill this knowledge space, or to kind of define the scope of what you are doing, and then kind of briefly explain the background of what you are going to do, so that it leads to the objective of the paper and the overall purpose of the experiment of the study that is part of the publication. Okay, so easier said than done. Your introduction, although should not be too extensive, but it should have all of these things, so that all the rest of the paper is perfectly set up for people to know what is coming and what they are going to expect in the experimental section and the results and the discussion. Okay, what the introduction should not be is an unclear hypothesis and a lot of rambling or padding, where nobody actually ends up knowing what you are talking about, except you are just filling space. Okay, so make sure you don't do that. That can be very disheartening to a reader, where they start reading the introduction and they find that it's not going anywhere, and suddenly the paper starts. Okay, don't do that. Okay, so in short, it's the hypothesis and the justification for the work that you are going to write up about. Okay, then comes the materials and methods section, or what we call many times as the experimental section. If you look at what this section is trying to do, the main aim of this section is to describe what you have done in such a way that anyone who is in that area of research, or who has a fair bit of expertise in that area, is able to kind of follow what you have written in the experimental section, so that they themselves can repeat the experiment based on what you have provided as information for the generation of a result. Okay, And this is very, very important. If you don't write your experimental correctly and kind of take out very, very specific details, then what happens is you're kind of standing in the scientific world sometimes gets questioned. Okay, and I'll give you an example of this, which happened to me a long time ago. I was trying to kind of grow an organism called as Bacillus megaterium in the lab. Okay, and many of you microbiologists might be familiar with this organism. Okay, Bacillus megaterium. It's very interesting organism. It contains the cytochrome P450, which is of a unique type, which is kind of fused to what is called as a reductase. And it's very, very efficient at metabolizing fatty acids. So I was trying to grow this in the lab. So I got the culture from ATCC, and then I started reading these old papers to find out what are the media requirements. And I found some and I started using it. But as I did that, I realized that when I started looking for media requirements, I looked at the author who talked about the media and said that the media used was based on this work, and he cited a reference. Then I went to that reference. In that reference also, the same author says that the media was obtained from this work. So I kept on going and actually went like 5 or 6 papers. Some kind of the original. Then you make sure that you also describe how they were validated so that you can continue to use them as part of this paper. Okay, and this is all part and parcel of your materials and methods. Now, once you have done that, then you start talking about the results you have generated, and this is the heart of your paper. Okay, and you have to remember that the results have to be stated very, very clearly and as simply as possible, unless you need to introduce complexity. Okay, and this is your contribution to the knowledge space. So remember that if you present the results perfectly, then only they actually add value to the knowledge space. If they are kind of a mishmash or jumbled up and nobody is able to make sense of a result, then it's almost as if not having a result. Okay, so make sure that as you generate information, you also correctly put them in what is referred to as a orderly and logical sequence as part of what your findings are. The only thing you should not do in the results section is don't be tempted to start interpreting the results here itself, because the section states that this is only results. A little later, what your results are telling will be discussed in the discussion section. So that's a separate section for that. So don't try to put it here. Now, in this regard, some journals actually have a section which is called as results and discussion, kind of put together. If that is the case, and then you are allowed to start discussing the results as you present the results. Okay, otherwise, in many cases, the result section and discussion section are two separate sections. So in the result section, you're not supposed to write anything about the discussion with respect to what you have found. It has to just state the results. Only that section is meant only for that. Okay. Now, in the result section, when you present your data, you can present it in direct text form, that is in sentences, or you can use what are called as tables or figures to assist in the people being able to look at the result you have generated or the information you have kind of organized. Okay. Now, remember that tables are useful when you have very large or complicated data sets, so that when you write it in sentence, somebody will get lost. So it's much easier to put it in a table in a very organized fashion. In the same manner, many figures, it could be a graph or a histogram or a bar chart or a pie chart. These are very, very useful when you have data sets which exhibit what are called as divisions between each other, or they display trends or patterns or relationships, which rather than talking about, is much easier to simply put it in a figure and convey visually. Okay, so you need to use these two tools of tables and figures very, very judiciously, because they will really, really help you to convey all the effort you have put in to generate the information which is part of your scientific work. Okay, and not only that, just like your overall paper needs a good title, your figures and tables should also have nice and relevant titles. And also in many cases, you'll find journals include a little caption or legend, which actually in short describes what is put in the table or the figure. Okay. The one thing you have to make sure you don't do is put the same information both as a table and a figure. That is just going to take up space. So either use a table or a figure. Rarely should you be using both of them, because if something is good enough in a table, you don't need a figure. And a figure is more appropriate, then don't put the same information in a table. Okay, that is just repetition and nothing else. Okay, so choose wisely what is more correct in terms of the data that you have. Is it a table or is it a figure? And then use it appropriately. Okay. Now, the results itself that you generate can actually fall under 4 categories. Okay, and I've got little cartoons on the side which look at this in a lighter sense. You may kind of look at it as I'm talking about this. The first category of results are the best ones. These are results that are clear and relevant to the hypothesis that you have stated. Either they are for it or they are against it. The second type of results are those which somehow appear relevant to the hypothesis but are not as convincing as those results in the first category. The third type of results are sometimes results that you generate using some hypothesis in mind, but the results themselves are indicative of a deviation from that hypothesis, maybe requiring you to modify the hypothesis or restate the hypothesis slightly differently. Okay, and that might happen. And of course, the category 4 results, which I kind of mentioned when I was talking about category 1, is results that are very clear and tend to reject the hypothesis. And these are also results which are relevant. Okay, so depending on what you have done, your results might fall under all of these categories. And therefore, they have to be presented in that fashion and discussed in that fashion. Okay. Now, the discussion part is where you either make it or break it in a sense. Okay, this is where all your skills of being a scientist and putting your thought towards the problem at hand and interpreting the results that you have generated are all put on display, so that the readers have a chance not only to assess your science but also your qualities as a scientist in terms of being able to make sense of the data that has been generated and thinking many times out of the box and looking at the non-obviousness of the results that you have generated, but which have got relevance. Okay. The end result of your discussion is to actually draw correct conclusions. Okay. And you have to remember that when you're discussing, you shouldn't make two types of error. One is results are indicating something, but you are not interpreting them correctly or under interpreting them. That means you are not giving due credit to what the results are telling, and you are being more very conservative for whatever reason. Or you might actually make the other type of error, which is even more dangerous, in the sense that you over-interpret the results so that it is in sync with your hypothesis, even though at first glance it appears not so. Okay, and this is a temptation which we all have because we sometimes forget how we have done the experiment and what are the limitations of the experimental design that you have, and that the fact that the limitation doesn't allow you to draw this conclusion is conveniently set aside as you decide to over-interpret the results. Okay, so don't make either of the errors, but in case you do make an error, under-interpretation is a little bearable, but to over-interpret the results is very dangerous, because your referee will immediately catch you and tell you, hey, this is not right. And therefore, after you send your paper, if a referee gets very irritated with your over-interpretation, your paper itself might be rejected right there, saying that this author is taking everybody for a ride, saying that these results are meaning this when they actually don't. Okay, so don't give a referee a chance to reject your paper because you are kind of thinking too much about the results in terms of what they mean. Okay, so make sure you draw only correct conclusions when you write your discussion. But this is where you actually get a chance to grow as a scientist, because writing a discussion is not easy. Okay, in fact, in my experience, when I have a lot of M.Pharm students and they start writing their theses, they end up in the discussion section writing the results again. Okay, discussion section is not to rewrite the results. It is talking about the results in terms of what they mean. Okay, so here it is very important that you discuss what you have found in relation to what is known or what is reported, and in relation to what is there in the real world, and what do the results mean in terms of their applicability. And when you start making affirmations or making statements in your discussion, you have to make sure that every statement that you make is either supported by your own results or by results which have already been reported and which you give reference to, or is it from an authoritative statement which you have heard from somebody and the person is willing for you to state in your paper that they are the ones who told you that. Okay, you will find sometimes in a reference they'll say the reference is so and so personal discussion with this person, and they'll state the name of that person, and that is allowed. Okay, so when you do discussion, make sure you don't talk in the air with no backup to what you are saying. Your backup to whatever you are saying is your own results and anything which is reported in literature or what you have obtained from a person who has got a fair amount of expertise in that area. Okay, and make sure that everything ends in a conclusion. Don't leave hanging statements in a discussion which others can take it whichever way they want. Okay, and again, make sure as you do the discussion, talk about the important aspects first and then the other aspects a little later in the discussion. So your discussion should not be the other way around, where people have to first look at things which are not really very relevant, and towards the end of the discussion is the most important thing. No, it has to be always the other way around. The most important aspect of what you have found has to be discussed first, and then other things which are kind of offshoots of what you have just found, which you also think may be of relevance, but which are of lesser importance. They'll come a little later in the discussion. Okay. And after all this, the last part of the paper is actually an acknowledgement of all the people who have contributed to research, both in terms of financial help. Many times you have to thank your institute, your funding agency, or the grant you have received, or a private company which has funded this research project. And also many times you have to thank others who have given what is called as physical and intellectual input. Maybe some testing was done in another lab and they wish for their person's name to appear as acknowledgement, fine. Or somebody who actually gave an intellectual input which helped you in writing the paper, but is not enough to merit authorship. Sometimes what happens is when you're writing something, for example, as somebody said, I want to know which statistical method to use. So actually talk to a statistician and say, okay, this is the best way to do this. And that information you use to actually do the statistics, but that is done by another statistician. Then the other statistician might merit authorship, but the first one does merit acknowledgement because they are the one who directed you to do this work. Okay. So here you'll find in the acknowledgement, funding bodies, use of facilities, use of equipment which are not yours, and people who help in the discussion or kind of writing the paper, all being acknowledged. And once you do this part, it ends with what are called as the references, which is all the support for the thought processes which have gone into kind of writing the paper and making the paper. And it also allows readers to go back and investigate whatever you have said in greater depth for two reasons. One, to maybe even verify what you have said, and second, to grow into greater depth of what you have said because they are interested in some other aspect. Okay, and here you will find references to other research articles, books, web pages, etc. And you will also find that depending on where you are sending the article for publication, the journals might have some rules in terms of how to format these references, and you have to follow that format so that it is accepted by the journal as part of your manuscript. But one thing you have to also remember that every reference you put, it has to be physically checked by either you or one of the authors of the paper, and that you don't do what is called as secondary referencing. Okay, that means you read one paper, there is one sentence which is given a reference, and then you say, okay, I'm also put the same reference without actually going and physically looking at that reference. Okay, that is not allowed. You have to check each and every reference before you put it as your reference. Okay, and once you have done all of these things, then you have a little checklist that you go through. Look at your title again, make sure it is specific and informative. Make sure your table or contents or abstract includes everything. Make sure the introduction states your main objectives, hypothesis, and there are enough information in the materials and results section for collecting the data. And all the tables and figures are titled correctly, numbered consecutively. They're all a separate entry and entries. And after this is done, you are ready to send the paper to publication for what is called as peer review, so that referees can look at it and give their comments either as a rejection or what is called as acceptance with minor revision, or acceptance with more work to be done, or acceptance with some major revisions, and so on and so forth. Okay. If you do things correctly, usually we are talking acceptance with minor revisions. Otherwise, again, a long sequence of same thing you have to go through again and again. Okay. So what I just said pertains mainly to what are called as research articles or what are called as research publications. Okay. If we talk about other types of articles, then the two other things you'll find you may be involved in writing is a review article. Now you have to remember, a review article is not an original article of your own research, but could be kind of compared to a research paper in terms of you discussing about results which have already been reported. Okay, so a good review correctly collects all the relevant information and gives kind of like an overall conclusion of the area in or the very specific topic on which you're writing a review article. And many times this will be articles which are kind of collected over a period of time and kind of all looked at in one shot and kind of collated in one place, so that others don't have to look at each and every reference to get a feel for what is the state of the art in a sense. Usually the wider audience is what you're looking at. The writing style is a little more general than a research paper, and you can be a little expansive here. You know, in that you can make statements which are many times a no-no in a research paper, simply because you are actually, as an expert, looking at whatever is there and giving your own interpretation of where the field of study is standing. Okay, so you get a little more leeway in writing a review article. Thesis writing is very different in that unlike a scientific paper, your thesis may describe more than one topic. It may actually have separate chapters which might be part of the overall thesis. And the difference between a research paper and a thesis is that in a research paper, you are many times constrained by the space requirements of a paper. In thesis, that is not a constraint. And in fact, you should be even more what you call as detailed in terms of how you write your materials and methods. You actually talk about all the things that you tried, finally which one worked out, and then the final optimized protocol that you have used, and so on and so forth. And so that people get a feel for what is the journey which resulted in the final result that was generated, rather than only the end result. Okay, so it's a little more involved and longer than a scientific paper. Again, it still has to be logical so that people don't get bored, because it's generally much bigger or longer than a paper. But thesis writing always kind of, in a sense, distills your entire journey over the time of the research that you have done, and may also include a lot of negative results that you have generated, so that others don't end up spending time repeating things for no reason. Okay, so that is the purpose of a thesis, to kind of tell whoever is evaluating your thesis what all went into the final information that you have generated, many times starting from method development or protocol development all the way to validating it and then using it to generate the final results. Okay, so it's more detailed. Many times it will be 100 pages or many times 400 pages, depending on what type of a degree you are talking and what type of research that you are talking. Okay. Again, just to very quickly make sure you are aware of originality and copyrights of others. You don't plagiarize. Don't copy anything without giving credit or referencing it. Take permissions as and when are required. And again, repeating your own publications again and again in different forms is plagiarism. Okay, so make sure you don't fall in that trap. And in the end, if everything goes well, you will get your publication. And many times your interest may be science or nature. But if you look at the area of research in general, many of us will also agree that many times the research that we generate is also negative. And there's always a question whether negative results can be published or not. Many journals do accept negative results if they are of relevance. It is not that all the time you need positive results only. Okay, so but if you look at that, you'll find that this journal of negative data will be the fattest of all because of all the failures that we typically have while doing research. Okay, and again, it's not easy. You have to live through rejection of manuscripts. You have to live through all the what you call as difficulties in trying to get your students to write the paper. Many times, if you are competing with somebody, they publish before you, you get scooped. You find the people who are writing the paper have other things to do. They are preparing for other exams. The last thing they want to do is write a paper. And then again, you're always fighting grand deadlines. You are not able to meet those deadlines in time because it is taking so much time to write the paper. Okay. And here are some cartoons. You can look at it a little later. I'm going to share the presentation anyways with the organizers. All the other aspects of science, which you can look at it also on a funnier side. Okay. Things like law of gravity. If you are told to reproduce the experiment, this is how it will be. Sometimes you do your work, there is so much error bar that you are afraid whether the data actually means anything. Or sometimes you have to need a telescope, and you can still see your error bars from using Google Earth. Okay, and make sure you write your paper correctly. Otherwise, you don't want this type of comment from an editor saying that your manuscript would serve some other good purpose if it was written on toilet paper. This can happen. Some reviewers are very, very harsh if you don't write the paper correctly. So sometimes you have to brace yourself for that. Okay. So make sure you don't give them a chance to do that. Okay. So thank you. And if you want some places where you can look at further, here are some books which tell you about how to write and a typical science paper. And bottom are my PhD students who I thank for helping me put these things together for this afternoon. So thank you. And if you have any questions, feel free.
So students, if you have any queries, any questions, you can type in the chat box.
Hi, madam.
It seems, sir, that everyone was very clear with the concept, with a complete flow chart. That's why there is no query.
Yeah. So there's a question which says how to prevent accidental
Okay.
plagiarism. We now have a lot of softwares available. Okay. Like for example, Turnitin, etc. What you are supposed to do is once after you write your paper, before you send it for publication, you run it through this proprietary software which you can actually purchase and have it in your organization. When you do that, it will catch accidental plagiarism, even though you might have missed it. Okay. And generally, the rule is, at least in our college, what we do is we keep our plagiarism check to below 5%, at the most 10. so that after your thing is done, if your plagiarism levels are below above 10%, then you have to modify your paper so that it comes down to less than 10, preferably less than 5. It is rarely 0, and the reason it's rarely 0 is many times you might put definitions in a paper or what are called as terms, which are standard terms. You have Turnitin, which might catch it as a plagiarism. So you have to make sure that the plagiarism report you check what all your software has caught as plagiarism, and if those are definitions, then you can kind of not worry about it. But if it starts catching sentences and discussion parts and results part as plagiarism, then you have to rewrite. Okay.
Hello,
Yeah, yeah,
sir. I have one question to ask you.
yeah, sure.
Sir, suppose we are writing a review paper,
Uh-huh.
and suppose there is a already written review paper. Suppose it is up to 2018.
Uh-huh.
Author has written a review paper, and I am writing the same review paper with slightly modified title, and I am writing it up to 2020.
Uh-huh.
So there are high chances of plagiarism, unintentional plagiarism, because I am also using the same data because I'm reviewing the data.
Correct.
So how much percent of plagiarism is allowed in that case?
Okay, now you have to remember that if you are good, you can actually write the review when you state that the review that you are writing is predominantly going to cover the last maybe 2 or 3 years of the science that has been done, and that the fact that the science before that has been adequately reviewed by this other author whose review appeared maybe in 2018 or so. Okay, and once you do that, then it is your skill to make sure that when you write your review, that you don't start invariably using sentences which were used either by the previous original research papers or the previous reviewer. Okay, you need
Okay.
to do that. You just cannot say, okay, because reviews were written and research papers were done, how can I prevent? Okay,
Okay.
your software will not accept that as a excuse. You still have to learn how to write a review such that you don't step over the previous reviewer or even the original research paper. So that's why you'll find that people write reviews over a period of 5 to 10 years so that this issue doesn't come up. Uh, unless, of course, that area is so hot that you could technically write a review in a year and a half because there have been so many publications. So you have to realize a typical review article, we are talking at least 250 to 300 new research papers in that area before you write a review. Okay, if in the last couple of years 10 papers appeared, then you don't actually, it is not worth a review. Enough work has to be done. I wrote one review once. I've written only one review till now, and that review had close to 350 papers. Okay, so unless you have that much work done, don't even try to attempt a review, because otherwise you'll not have enough to write a review and you'll start repeating what has been done previously by the other reviewers. Okay.
Sir, how much percentage of plagiarism is allowed in such cases? I mean, 5%, 10%.
It is a general rule, never more than 10%. In fact, 5% is what we call. And it is not different that if it's a review, more is allowed. Basically, plagiarism means less than 5%.
Sir, can you kindly suggest some apps or website so that for plagiarism checking?
The
So
one
which is
is
internationally accepted?
the one which is really, really good, but which is a little costly is Turnitin.
Turnitin. Okay. And
There are others also which are given by other vendors, but our experience has been that they are not as complete as Turnitin. There are softwares which, if you pay more, they do a more elaborate research on what is there in the net. But we find Turnitin is fairly good and it is accepted. Okay,
thank you, sir.
it in. Yeah,
Okay. Thank you, sir.
yeah.
There is a small announcement for all the students that before leaving, there is a feedback link. So do share your feedbacks. And sir, before we move forward to the formal vote of thanks and concluding remark, I really want to appreciate the way of explaining ideas for type of plagiarism using Bollywood songs.
Yeah, yeah.
So I think students को ये भी याद रहेगा plagiarism because they can easily correlate with Bollywood songs.
Yeah,
Thank
I
you so
hope.
much.
Yeah, welcome.
Okay.
Uh,
So
yeah.
yes,
I still feel, and I told madam that as for some reason online is not as fun as offline. I
yes,
wish
yes.
hopefully at some point we get back to our
Definitely, sir. We will plan. Definitely.
Yeah.
Sure.
Okay.
Yes, just a minute, Sneha ma'am. Actually,
Hi,
thank you, sir.
Hi.
My voice is audible.
Yeah, very.
Hello, sir.
Hi.
Sir, actually, I wanted to thank you personally. Otherwise, vote of thanks, Sneha madam will be giving shortly.
Yeah.
One thing is the way you have taken the flow of scientific publication. I liked it because even I teach that paper. So now I have also learned the concise way you have given. The second thing is now in my presentations also I will try to incorporate cartoons so that students will understand.
Yeah.
And as you said, ki offline we will be definitely planning some more sessions now in feedback means we have asked them for the topics, other topics which could be discussed so that we will definitely take it.
Yeah. I have one favor to ask you.
Yes, sir.
Yeah, I needed to convey my good wishes to Seema ma'am. I
Yes,
don't know
yes,
whether
sir.
she's there in the audience or not. If not, please say hi from my side.
Yeah, actually examinations are going on. I will convey the message to ma'am.
Yeah. Please do.
Yes.
And hopefully we'll
Okay.
meet up at some point. Thank you.
Yes, sir, definitely. In this term only we'll try.
Okay. Bye.
Yes. Okay. Sneha ma'am, you can continue.
Okay, ma'am. So, myself Sneha Pandey. I'm here to give a formal vote of thanks. So, firstly, I would like to thank Chairperson of Dombivali Shikshan Prasarak Mandal, respected Prabhakar Desai sir, for giving us the opportunity to conduct this workshop. I will extend my thanks to respected Principal Professor Dr. K.R. Jagdev sir for his continuous throughout support and coordination. I take this opportunity to give a special thank to our IQAC coordinator and vice principal, Dr. Suman Satyaran, for arranging this research workshop. It was really needful for all the students. Thank you, madam. I take this opportunity to thank our vice principal, Dr. Ashwani Bakkar, ma'am, and Ms. Sheetal Dogle, madam, for their encouraging coordination and support also. Thank you so much. Next, it comes to our motivational and really intellectual speakers for both the days. Starting from day one, session one, Professor Dr. Moshmi Datta. And she has given a very insightful, uh, meaningful basics on fundamentals of research, like how to write, how to study, how to find out the causes and the solutions related to research paper. Then day two, in day one only, the session two was given by Dr. Shraddha Bhume. She has given insights on research which is based on primary and secondary data. Also, she told us and manually that how to prepare the questionnaire for the data. Day two started with Miss Rajeshwari Madam, which has given a live workshop on the data analysis using statistical tools in Excel sheets. uh, for example, like ANOVA, chi-square, correlation. So students have taken so much of enthusiasm to learn on the Excel sheet because Excel sheet sometimes it's very difficult. So thank you so much, ma'am. And the day for remarkable session was ended with Professor Dr. Krishna Iyer sir, who has actually started with a bird's eye view on crafting and publication, how to write from each and every step, starting from abstract to how to conclude the paper. So thank you so much to all the motivational speakers of our session. Really, I'm sure that all our students must have encouraged toward the research. Next, I would like to thanks to all our energetic, enthusiastic, and the future research students, okay, for such an appreciable involvement in the discussion. Next, I will take the opportunity to thank all the faculty members who have joined, taken some of the time to learn and listen this research horizon. Next, I would like to thanks to all the members of IQAC committee, management staff and technical team for all the arrangements to make this workshop a success. Thank you so much. I declare that the session is over, but students, I still remind all of you that there is a feedback link provided in the chat box. So all of you, without fail, fill the feedback link, and also we will share with you before the evening, we will share with you a questionnaire. So you have to fill the questionnaire also. Later, we will provide you e-certificate for this. Thank you to all. I declare the session is over. Thank you so much.
Thank you, ma'am.
Students, now you can leave the meeting.